All right, in this video, I'm going to focus on the standard normal distribution and using Excel to answer questions relating to this distribution. Now, there's going to be two main types of problems. And I have down here at the bottom these three green and red graphs. I have the Excel functions for these two types of problems. There's two main Excel functions. There is, let's see, let's go with blue. There are two main Excel functions. There's the normal distribution function and there's the normal inverse function. Now the difference between these two is that the normal distribution function will give you area if you know a z-score, and the inverse function does the opposite. It gives you the z-score if you know the area. Okay, so hopefully you've watched my, you've gone through my PowerPoint notes and watched my video. I've gone through all these Excel functions in detail in my notes, so now I want to actually apply some of them. Okay, so we have 7 problems. Actually, there's 8 because we're going to do number 7 twice. And for each problem, I think it's very helpful. You know, even though we're doing everything on Excel, it's helpful to have paper and pencil next to you and you sketch a graph and label the graph for each problem. And that's what I'm going to be doing in this video. I have some blank graphs down here, and as we work through these problems for each problem before we calculate on Excel, we're going to go ahead and just draw a quick sketch of the graph. Okay, so let's start with number 1. Find the probability that z is less than negative 1.14. Now, remember, this is the standard normal distribution. So this is assuming all x values, all data values have been converted to z-scores. I'll deal with the non-standard distribution functions in my next video, but basically in these Excel formulas down here, it's the S, the dot S in the middle, that stands for standard. So anytime you're using a standard normal distribution, you need to have that dot S in there. Okay, so number 1, find the probability that z is less than negative 1.14. Remember, the words area, probability, proportion, percentage, these are all interchangeable with these continuous probability distributions. So finding the probability means finding the area, or finding the area means finding the probability. Those two words are interchangeable. Okay, so we want the probability, or the area to the left, because it's less than, the area to the left of a z-score of negative 1.14. So let's just draw a quick sketch over here on the graph. This is the horizontal axis, is the z-axis. Okay, so we're doing number 1. A z-score of negative 1.14. So we know the z-score, and we want the probability that z is less than. Let's see if we get, yeah, we want the probability that z is less than negative 1.14. So we want this area. We want this area to the left of negative 1.14, and for that we're going to use the this Excel function here, equal norm.s.dist. So that's the normal standard distribution function. Okay, so for number 1, equal norm.s. distribution. Remember, if you click on when Excel sort of auto completes the function you're using, now Excel is saying, okay, in parentheses we need the z-score, and then we have the cumulative question, yes or no. With continuous data, now this is important, with continuous data, there's no question. You don't even have to think about it. You always, 100% of the time, use the cumulative function. That's why it's always going to be a 1 at the end. If you see my Excel functions down here, there's always a 1 at the end. Okay, so the z-score, negative 1.14, and cumulative 1. Remember, in Excel, 1 means yes or true. All right, and so that's it. So a little more than 12% of the area, or an area of 0.127. Now, Excel, whenever you're using these Excel functions, you're talking about area with the continuous distributions. Excel only works to the left. Excel only does less than. So in problem 2, find the probability that z is greater than negative 0.77. Well, here's negative 0.77 on the z-axis. And we want the probability that z is greater than that. Greater than means to the right. So we want area to the right. That's the question. Excel can't give us that. Excel could only give us area to the left. So what we do is we use this function up here on the right. So the area to the right of the z-score, which is what we want. So this is like the complements rule of probability. If we know the entire graph has a total area of exactly 1, then the area to the left should be 1 minus the area to the right. Okay, so that's what this function over here on the right is saying. 1 minus, so this right here, this is area to the left of the z-score. So if we do 1 minus the area to the left, or basically, if we figure out this red area, well, the red area plus the blue area has to be 1. So if we take 1 minus the red area, that will give us the blue area. Okay, so let's come up here and see if we could answer this question. So the probability that z is greater than negative 0.77 should be equal to 1 minus the probability that z is less than negative 0.77, or 1 minus norm dot s dot dist for distribution. Our z-score is negative 0.77 and cumulative always 1. Okay, and now the third, so for number 1 we had this situation, area to the left. For number 2 we had this situation here, area to the right. And now for number 3 we have the area in between two z-scores. Oh, there should be a z2 down there. Let's just put that little z2. Okay, so 2 z-scores, z1 and z2. All right, so now if we want the percentage of data between 0.23 and 1.88. Remember, percentage, probability, area, they all mean the same thing in the context of continuous probability distributions. Okay, so we have 2 z-scores. We have positive, so this is a z-score of 0. We have positive 0.23, and we have positive 1.88. And so what we want is, we want the area between these two z-scores. So what, and again, Excel could only give you everything to the left. So what we could do is we could start off with everything to the left of 1.88, which is too much. That's more than we want. So if we start off with all of this blue area, and then we subtract off what we don't want. So basically, if we take all that blue area, that's here. That'll give us the blue area. And then we take away what we don't want, which is the red area. Okay? And that will give us the area between 0.23 and 1.88. Okay, so let's pop that into our answer for number 3. So the area between should be equal to norm.s.distribution. The larger z-score is 1.88. Okay, so that's all of the area from 1.88 down, or 1.88 to the left. Then we will subtract the red area, norm.s.distribution, and our smaller z-score is 0.23. Okay, so that should give us the area between the two. All right, perfect. Now, for numbers 4 and 5, now we have the other type of problem. In numbers 1, 2, and 3, we were, let's separate these. In numbers 1, 2, and 3, we were asked to find the area, find the probability. Now, for numbers 4 and 5, we want to find the z-score. So in 1, 2, and 3, we're given the z-score. We wanted to find the area. Now in 4 and 5, we are given the area. We want to find the z-score. And that's just basically the opposite or the inverse of what we did in the first 3 problems. And to do that on Excel, it's the inverse of the normal distribution function. So if you look down here, the .inv stands for inverse. That's the one you're using when you're looking for a z-score. Okay, so find the z-score that separates the lower area of 0.087. 0.087. Now, we know half of the graph is half of 1, so the left half is 0.5. We want 0.0. Oh, no, I'm drawing that in the wrong place. We want the lower, let's make that a little bigger actually. We're given that the area equals 0.087, and we're looking for the z-score. Okay. And the normal standard inverse function. All we need in the parentheses is the area, and that's given in the problem. That's the 0.087. So let's come up here to answer number 4. The z-score that separates the lower area of 0.087 should be norm.s.inv for inverse, and the probability, which is area, 0.087. And we should definitely be expecting a negative z-score because it's to the left of 0. And yep, negative 1.36. All right, so number 5 is well, it's similar. We're looking for the z-score, except we're given the upper area. We want the z-score that separates the upper area of 0.556, or a little more than 55%. Okay, this was 4. This is 5. Okay, so here's the z-score of 0. And we want the z-score that separates the upper area of 0.556. Again, and this is really, really important, Excel cannot work with area to the right. Excel could only work with area to the left. So let me just give like a quick example with maybe easier numbers to work with. Let's say we're given that the area to the right is 0.3. Well, we could easily determine the area to the left. It's the rest. So the whole graph has an area of 1. If there's 0.3 to the right, the other 0.7 would be to the left. So for this particular z-score, it's two ways of saying the same thing. 30% is to the right, 70% is to the left. Okay. But the important thing is that Excel can only work with area to the left. So we need this area. And for this area, we'll just take 1. We'll subtract off. So this area equals 1 minus the 0.556. Okay. So if we subtract, if we say 1 minus 0.556, that should be 0.444. Okay, so that's what Excel needs. Excel needs area to the left. All right, so let's come back up here. And this is equal to norm.s.inv, and the probability, or the area we're going to use, is 0.444, and we should again expect a negative z-score. Yeah, looks good. Okay. Number 6 is regarding critical values, and I talked about these in my notes and my video lecture on this section. So z alpha, z with a subscript of alpha, it's the z-score that separates the upper area of alpha. Now alpha is a number, alpha is going to be given. So in this particular problem, alpha is given as 0.05. Alpha is 0.05. And now that 5%, that 0.05, is split half above and half below. So find the critical values that separate the middle 95%. The middle 95%. Okay, so let's draw a quick sketch here. Okay, so we have the middle, we'll shade the middle 95% of this graph. Okay. Now we want these z-scores that separate the middle 95%. Now, because the graph is symmetric, they're going to be the same number. One's going to be positive, one's going to be negative. Now, again, Excel only could work with area to the left. So let's see if we could figure out this area to the left. Well, if the middle 95% is between these two z-scores, well, the other 5% has to be here and here. So that other 5% is split. That other 5% is split half on the left, half on the right. So 2.5% or 0.0 0.025 on the right, and the other 2.5% or 0.025 on the left. And that's what we're going to be using here. We're going to use Excel to figure out the z-score using area to the left. Okay. So we could apply the same function we used in number 4 and number 5, the inverse of the standard normal distribution function. Okay, so those critical values should be norm dot s dot inv with the probability or area to the left of 2.5% or 0.025. Now this is going to give us a negative number. The critical values are plus or minus. So a negative 1.96 and a positive 1.96. Those would be the two critical values. Those would be the two critical values, 1.96 and negative 1.96. Okay, let's free this one up. All right, and so number 7 will segue into the next Excel exercise, which will be in my next video, the non-standard normal distribution. So all of these problems we're using z-scores and standard normal distributions. For number 7, the social organization Tall Clubs International has a requirement that all women must be at least 70 inches tall. Okay, we're going to need that. Given that women have normally distributed heights with a mean of 63.8 and a standard deviation of 2.6, find the percentage of women that satisfy this height requirement. All right, so there's two ways we could do this. So when you're presented with a problem with a non-standard normal distribution. Remember, standard means the mean is 1 and the standard deviation is, or the mean is 0 and the standard deviation is 1. If you have any numbers other than 0, 1, it's a non-standard normal distribution. That means you have a mean, a standard deviation other than 0, 1. So we can use the non-standard distribution function that's built into Excel. That just means you drop the .s. Or we could convert. So here's our, let's see, here's our x value. X equals 70. So we're basically saying in this problem, what's the probability that x is greater than 70? What's the probability that x is greater than 70? Or we could convert that 70 into a z-score. So let's do it both ways. So we have a mean of 63.8. So a mean of 63.8. And the x value we're looking for here is, that we're given, is 70. And we want to, and you have to be above 70 inches to qualify. So we want the probability that x is above 70. Or we could convert to z-scores with a mean of 0. We're going to have to convert 70 into a z-score. Either way, we're looking for the same part of the graph. Above 70 or above the z-score for 70. So these are, let's see, this is the the horizontal axis here on the left is the x-axis, and the horizontal axis here on the right is the z-axis. Now it's up to you. You could always convert to z-scores and use the standard distribution function, or you could stick with the x's. And Excel has a function for both. It's really just personal preference. So the first thing is we'll have to convert 70 into a z-score. Now remember, our formula for z-score, z is equal to x minus the mean divided by the standard deviation, which in this case would be 70 minus 63.8, and divide that by the standard deviation, which I believe is 2.6. Yeah, standard deviation is 2.6, so we'll divide by 2.6. All right, and that's what I have here. Actually, this should say using x. Oh, no, using z. That's what we're doing here. Yeah, using z. Okay, so our mean is 63.8. Our standard deviation is 2.6. Our x value is 70, and z-scores are equal to the x minus the mean, and all of that divided by the standard deviation. Okay, so we have a z-score of about 2.38. So the number 7, in this particular case, the number 70 converted to a z-score is 2.38. So the area to the right of 70, the area to the right of x equals 70, or the area to the right of z equals 2.38, should be the same number. Okay, so if we convert to a z-score, now we know we want the area to the right of this z-score, which again, just like problem 2, Excel could only use area to the left, so the area to the right is going to be equal to 1 minus the area to the left. So the red area should be 1 minus this blue area. Okay, so equal 1 minus norm.s.dist, the normal standard distribution function. Our z-score is down here in B15, and we always use a 1. Okay, so a little less than 1%, of women qualify for the Tall Clubs International. Now, an alternate, and this is, I'll be covering more in detail in my next video, but an alternate way is to not convert to z-score and not use the standard normal distribution and just use the regular normal distribution. And so in Excel, that's equal norm.dist, norm.dist. And when we select that, well, now Excel needs to know the x value, also the mean and the standard deviation, and all that's given. So the x value is 70. The mean is 63.8. And the standard deviation is 2.6. Now remember, what I've typed in right here, this is the area to the left, or this is the probability that a woman is less than 70 inches. So we want the complement of that. We want the area to the right, so we need to put a 1 minus. We need to put a 1 minus in front. And hopefully, fingers crossed, we get the same 0.0085 485. You entered too few arguments. Oh, you forgot the... Always need the comma 1 at the end for the cumulative function. Yep, looks good. So, convert to z-score, I think, is a little bit more work. The thing is, if you're using the textbook method, which is a table of values you could find in the book, that method only works for z-scores. So if you're not using Excel, if you're using basically the table of areas, the table of areas and z-scores, you have to do that conversion. But with Excel makes it easy. I would say, my preferred method is to, if your problem gives you X values, stick with X values. If your problem gives you z-scores, stick with z-scores, because Excel has a function for both. So there's really, if you're using Excel, there's really no reason to convert between the two. Okay, so that about does it for this video. The next video will focus primarily on the non-standard normal distribution function. Okay.